Jump right into it. Well, thank you, everyone. And thanks for the OWASP committee for allowing myself and Ethan to present this Friday afternoon. We're super excited, and my coworker Alex is going to be joining on the presentation as well. So I'm going to go ahead and get right into it. So Data Theorem, we focus on API security, web security, cloud security, and mobile. Couple years ago, I've been a pen tester, and before a pen tester in the 90s, I did some other things that didn't really have a cool title, but I've been in the hacking scene for quite some time. And about 2 years ago, I noticed some attacks happening on APIs that were, I thought, coincidental. And it turned out it wasn't. It was some pretty cool techniques that are still happening today. So that is the topic of my talk, is not only how to hack your APIs in 15 minutes or less, how hackers right now are doing it in 15 minutes or less. So this is more like a case study of what I identified from some reconnaissance and some of my friends still in the industry with unknown titles. So I hope you enjoy it. And then I'm going to just dive right in. So one thing I want to talk about, the main importance of this slide is 15 minutes or less. The hacker community, and I'm not talking about the research community or even the professional community like Data Theorem, but the hacker community is quite efficient. They have a lot of things to do, whether it's hanging out with friends, trying to get their driver's license, or eating a bag of Cheetos. They're a very efficient crew. And so 15 minutes for a target, unless you want to take down that target or unless it's a nation state, 15 minutes, it's about the maximum time you're going to have a hacker going after you. For like a drive-by attack. And that's what my first thing is. Hackers hack, right? That's what they're here for. That's what they want to do. They do it for fame, sometimes just for chaos, sometimes to entertain themselves and their friends, and sometimes for money. Now later, when, in the past decade, it's become monetizable, but in the 90s, no one was really making money off of hacking. Organized crime was always there, but it's gotten even more efficient. But this is something that, hackers are here to hack. But it's different from research. Research is very different from hacking, security research, that is. So one person on our board who doesn't need an introduction, Dan Bonet, he's a professor here at Stanford. He's a true researcher. He has taught me so much about the information security community, information security market. And his students over at Stanford, his PhD students, they're great research. They produce great things, but it's research of security. It's not hacking. And so because I grew up in this world in the 90s, the researchers are what I call the Diet Coke of evil. Like many researchers would never, ever break a law. They would never maybe even hack itself, which is actually pretty easy with test environments in the cloud these days. You don't really have to choose a target to learn. There's so many other places to learn. But it is not an evil thing to do security research. You're not breaking any laws. But when I was much younger in the 90s, we didn't have that luxury. It was a hacking community. There were no test environments. And so my friends, because I kind of call out post-2015 security is really strongly and more technically research-based. But sometimes I'm known to be a grumpy old man saying, hey, if you've never hacked anything, it's a different mindset of hacking. It's about efficiency, it's about data, and it's about getting in and getting out. It's not for the intellectual stimulation. It's not for the research. It's very different reasons. And this is what I identified with this API hack that we'll be talking about today. All right, so before I talk about that, let me talk to you about some of Dr. Dan Bonet's research and other research from the academic community. So this I thought was pretty clever and kind of distinguishes a hacker from a researcher. Here is a great paper from some universities of how machine learning can be defeated, essentially. So you and I and everyone probably watching this is probably seeing a stop sign. It's pretty international. Maybe the language changes across the globe, but the stop sign is pretty, at least here in the United States, pretty known to all of us. We all would say this is a stop sign. believe it or not, these stickers on the stop sign make certain machine learning algorithms not recognize this anymore as a stop sign. So this no longer looks like a stop sign to some machine learning algorithms. And the great students of these universities basically did this intellectual research to basically prove machine learning can be defeated. Yes, machine learning can be defeated with 4 stickers on the stop sign. Very impressive, very impressive. So as someone like me, when I was much younger, or maybe even today, what I would do is probably not take months of research from very intelligent students from great universities. What I'm going to do to defeat machine learning is I'm going to take a stop sign and I'm going to go sit on 101. And if you're here in California near Silicon Valley, 101 is our major highway here. And I will just stand in the middle of the highway with a stop sign. And you can see a Tesla here. I'm not picking on Tesla. It could be any smart automobile that recognizes the promise of self-driving cars, which I love and I will happily do one day. But self-driving cars will see stop signs and they will stop. So what happens if they see a stop sign on a highway? Will they know that an immature adult like myself is holding the stop sign and just ignore it, which is the safe thing to do? Or are they going to continue and listen to the stop sign and stop on 101? And so you might be saying, or maybe someone on Tesla is saying, listen, we figured this out. We know we're on 101. We know we're going 65 miles per hour. We know there is no way there's a stop sign here because we know this highway. This will not be possible. And I don't know if that's true. Maybe someone in the audience does. In the Slack channel afterwards, I would love to hear about more. But let's say, that's true, right? But look at this construction worker. This construction worker is on a small highway somewhere probably in the Midwest here in the United States. And they're doing some construction work. It might be emergency construction work. So what is the difference of me on 101 with a stop sign and this construction worker on a stop sign, right? This is like real-time emergency road work, and this construction worker is obviously stopping cars, right? So this is my answer to like the 15 minutes. When you're a hacker, you're not trying to defeat TLS. That's like multiple months of research, if not years. You're trying to hack and get data. So the point I'm going to make next will really come full circle with API security because of the recent data breaches we've seen in the last 3 years with APIs. It's not sophisticated. It's hackers running wild on API security, and here's what they're doing. So don't listen to me. Don't listen to Data Theorem. Look at the news. Look at the data. So 2 years ago, there's this app called 63 Red Safe. It's a mobile app. And essentially, it was in the news because an API that the mobile client was connecting to had no authentication required. So this happened in March 12th of 2019. My company, Data Theorem, we found out about it because it involves mobile and API. So we're like, oh, interesting. Now, we obviously look for that constantly since 2016, but it was cool to see that the awareness of API security was getting out there as it pertains to mobile or not mobile. But here's the interesting part. Later that year, the exact same thing happened with the exact same researcher. Here's an app in Australia with an API search operation. The other one was a different operation. This is a search operation, also in a mobile app, and the attacker was able to get the first name, last name, email, date of birth, Facebook ID, and phone numbers, all through an open API out there on the internet, right? September 19th or September 9th. September 27th, 3 weeks later, same attack, different app. Same attack, different app. This is Heyo. This is an Elasticsearch database embedded in the mobile app, also identified by a hacker, also publicized here in the news. December 23rd of the same year, again, same attack, API response operation embedded in a mobile app, and also compromised first name, zip code, basically location information just a couple months later. So at this point, it's not a coincidence to me. At this point, I know someone, either a group of hackers or researchers, what they call themselves now, are figuring stuff out. They're putting things together either as a group itself or as a copycat attack, but there's too many attacks on the API targeting mobile clients and successful all at the same time, right? No one's that lucky all the time. So it goes on to the next year, our favorite year, 2020, the year of COVID, and June of 2020, it could go on and on. But here's something just 2 weeks ago. This is also in the news. On September 17th, so this paper, this article came out saying APIs lacking authentication controls can allow anyone, including threat actors, to potentially hit sensitive information. And 2/3, if you read the title of this article, 2/3 of misconfigured API, 2/3 of cloud breaches, which is why we're also a cloud company, not this API. 2/3 of cloud breaches are because of misconfigured APIs. And I'm going to show you how that's successful. That's the whole point of our talk today, that is something we've been knowing about 2016. This hacker group in 2019 knew about it 2 years ago, and now the rest of us are catching up, obviously this article. And one thing, if you're into API security, you're probably something aware of the BOLA attack, broken object something authentication. It's a great attack. I love it. Very sophisticated, very research oriented, right? And that's why I'm not going to talk about it today, because it's not the cause of data breaches. Data breaches are happening much easier than BOLA. Now, BOLA is great. I love it, but it's a researcher exploit. APIs are being breached in a much easier way. And you can see from this article, 2/3 of cloud data breaches are because of the API. So I cannot agree with that more. Okay, so how did this happen? All right, so this is the cool stuff, right? So this is what that I figured out back in 2019 was happening. So this is what that you can do yourself, and we're going to provide some tools to allow you to do it yourself as well. So what we're going to do is we're going to go to the App Store. There's a lot of ways to do this, but I'm going to talk about how to do this, how the hackers did it in 2019. We're going to go to the App Store, and we're going to download any app we want. I'm choosing Amazon because it's a random name that I remembered this morning. There's nothing wrong with Amazon. There's nothing wrong with the app. This is just an app on the App Store. So the first thing we're going to do is take an app from the App Store, and we got to decrypt it. That's step number one. And here's a screenshot of us decrypting it. And I'm going to now share a video of us doing that so you can see it in real time. So I'm going to switch back and forth for your pleasure. So this is us decrypting the Amazon app. The Amazon app is on the right side on the iPad, and then the left side is our code. And when we're decrypting it, which is depending on what technologies you have or how comfortable you're with, it's not very difficult, right? So decrypting an app from the App Store, removing the DRM, something pretty standard. And so that's done here. So that's all decrypted. And now we're going to take the decrypted app and put it on our analyzer farm. So I'm going to go back to the PowerPoint. All right. Now, step two is detecting and basically decompiling the app to get to its source code. Remember, this is a binary in a public cloud. We call it the App Store, but it's still a public cloud. So we took Amazon's app from the App Store. It could be Netflix, could be anyone. And we're going to decompile it. And now we're going to go and hunt for APIs. So my coworker, Ethan, who's going to take over in a second, wrote this tool called API Hunter. We're going to release it to you all to use and play with afterwards. He wrote a tool called API Hunter that essentially is going to look for APIs in the Amazon app, right? Very simple. So I'm going to just show that in action. So give me a quick second. All right, so here's Ethan's tool. And so now what he's going to do is, you can see at the top, API Hunter is going to be executed on the Amazon app. Little typo there. And now he's hunting. He's not threat hunting, he's API hunting. So all the APIs that he's identified on the Amazon app from its public binary are showing up here in light green. And again, we're going to show you how to automate this together. But so far, we've done nothing special, nothing new, no BOLA attacks, all very simple stuff, right? Going through it step by step, just so you all know. And so I'm going to go back to my slides. So far, we've taken the app from the App Store. We ran API Hunter on it, and we got some APIs, right? All good. Now, here's the clever part. This is the clever part, and I applaud this hacker group that do this 2 years, because remember what I said about efficiency in the beginning of this? What they did is they took the Amazon or any app today and they sat on it. They didn't do anything. And this is clever. This is why hackers are very efficient. And then the next release of the app, or maybe 3 releases now, they did a diff. And they looked at the app from 3 months ago to today, and then they figured out what's new. What are the new APIs? And this is why hackers are so clever. The reason they were targeting only the new APIs in a big or large organization, or big or small organization, what's usually going out the door has a higher success ratio of being hacked than something that's been in the app for years, right? And the reason about that is because developers have a lot of control now. They can push out code, and the security team may be behind if it doesn't have a product to look at that code in real time. It could be missing new APIs that are happening or that are being released out to the public. So if you're a hacker and you want to get in and get out and not waste your time, you're going to target the new APIs only and not the old ones, because the success rate of targeting new APIs is much higher than something that's been there forever. So Ethan has done that as well. So let me go ahead and show that. Sorry, let me just share that slide. All right, so this is a demo of his tool. And now he's basically finding the new APIs, the brand new APIs from diffing the old Amazon app here in April to the one from today. And so the only thing that his tool is going to show is the new stuff from today. And this is what you're going to target with your attack script to go basically get some large amounts of data. So this is all automated. Like, this is all the new attack surface. Bam, I have a new attack surface, and the likelihood that I can attack this is much higher than something, again, that's been there forever. All right. All right. So at this point, all you have to do is connect to the APIs. You connect to the APIs. Now, this is the sample part. The next part I'm showing you is all sample. This has nothing to do with the Amazon app, but this is the type of data those hackers were getting in 2019 and 2020. They were getting first name, last name, username, password hash, social security number. All they did is do a diff of the binary, found the new APIs immediately, connected to those new APIs, and bam, they compromised large portions of data. So that article I showed you, have 2/3 of data breaches are happening on the cloud because of APIs. This is how it's happening. It's not some sophisticated multi-step triple bank shot BOLA attack. It's hackers targeting the brand new stuff, the stuff that's straight off the assembly line, connecting to them at scale and getting data at that can be sensitive. Not all the data is going to be sensitive, but the data that they're getting 1 out of 10, and they just need to have it once, is going to be is for their case sensitive. And so the beauty of this as an attack is, if you're a hacker, what do? You decrypted, you diffed, you connected, you extract. You can script that. Like, I showed it to you one by one, but you can script that to do it automatically. And then you can target literally millions of APIs, millions of mobile apps on the App Store and Play Store, millions of single page app and server labs. The attack target is so huge that if you don't target one company, you can target thousands and millions with this script. And again, this is what the hacker community was doing for API security. So I'm going to shift gears a little bit and I hand it over to Ethan to talk about the science of these tools. We're going to release these tools right after this talk. So Ethan, would you mind talking about the details of these, please?
Yeah, thanks, Himanshu. So what we're looking at here is the Python script that performs that initial analysis that you showed, where we find all the APIs within the decrypted application bundle. And like you said, Himanshu, this is really easy stuff. There's nothing complex here. So what the script is doing, we look at every file that's within an application bundle. Applications are made up of a lot of files, binary files, SDKs, text files, images. We'll search through every file within that application bundle and use the strings command to dump the list of strings that are in each of those files. So that gets us the entire list of strings within each of those files in the bundle. Now from there, we're going to use a regex expression against those strings to narrow that full list of strings down to items that look like they might be APIs. They have HTTP, HTTPS, they follow the general URL format. Now, we don't need them to have API or any specific keywords in there to look for it. The regex expression is pretty comprehensive in that. So when we run this against the application bundle, it prints out the list of every single URL within the bundle that looks like it may be an API. But keep in mind, this is a simple regex expression. So we don't expect the results to be perfect. We expect some of the findings that we get out of this to, maybe they're not reachable or anything. So that's why it's important to follow up this step by attempting to connect to each of those APIs that you found. So what we're seeing here is, kind of a flow chart that describes, given a potential API, if a connection is made to that API and the resulting status code is 404 not found, well, that means we can ignore it. It's not a real API. It's not reachable. It's a waste of time, right? Now, if it redirects or we get some other type of server error, those are also indicators that this is not a real URL or a real API. Now, if we get a 200 to 209, that's all good, right? That means that we were able to connect successfully, no problems. If we get a 403, which is an authentication error, that's still a green light. If we get a 403, that means that we found a real API and we tried to connect to it, and it just told us, no, you can't connect here without a password. Remember, we're doing API inventory here. So we only care about figuring out which APIs are real and valid, not necessarily worrying about the authentication scheme of them. Those can come later. All right, so another example of running that Python script that I just described against an app bundle. And you can see here that pointed it to an application called apollo.app, and it printed out all of these strings that look to be APIs. These are in specific for the Reddit website, but you'll notice not all of them contain API. Some of them have weird formatting. Some of them may not be URLs. So again, that's why it's important to connect to these to validate.
Oops, sorry.
All right. So what we're looking at here is the output. Like Himanshu said, shadow APIs are a great target if you want to, save time and only target impactful new APIs. And the way you find these is using that same script I just described to dump the list of APIs out of, one version of the application. You're going to do the exact same thing, but with a different version of the application. So there is a requirement here that you've held on to, a decrypted version of this app. It's a little bit older than the one you have now. And you're able to run the script against both of those bundles. And then with the resulting URLs you get from each of these, you diff them. And the diff is the net new APIs that have been recently added to the application. And like Himanshu said, there was probably a lot less scrutiny on the APIs that just popped up in apps yesterday versus the APIs that have been in the application since it shipped a few years ago. So if a hacker is really trying to save time and root someone in 15 minutes or less, targeting these shadow APIs is really a great strategy to go towards.
Yeah, and thank you, Ethan. And this technique is not new. What Ethan and the team observed and what we found from the hacker community and what we do at Data Theorem is cool stuff on new API tech. But this technique actually came from the 90s. Like, if I can date myself, when a Microsoft, and yes, that used to be an operating system everyone used, when they used to come up with a service pack, what you do is you take that service pack and you essentially look at what the service pack is updating in the OS, And that's where you know to look for if there's any security changes in the OS. And that's how you know there's an exploit. And if you're gray hat, you're essentially a worm in the 90s, and that's how all these worms became successful, because Service Pack 2, Service Pack 3 would patch a security issue, and no one upgraded service packs for 6 months, and hence you have a worm. So this technique is not new. It's just being applied on APIs now within 15 minutes, and you can see from 2019 to all the way to 2 weeks ago, it's still successful. So in summary, the way to make sure you as a researcher can find this, use our tools or use this technique and implement this. Don't stop doing security research. We do it all the time, but don't forget about the efficient hacker. They want data, they get in, they get out, and they do it at scale. And if you're on the other side, on the protection side, inventory your APIs, just like the hackers are doing, and test for authentication authorization as much as possible. And at that, I think we're out of time. And so if there's questions, my coworker, Alex, will all be in the Slack channel. And if you want to contact Ethan, the mastermind of this presentation, and get his tools, feel free to email us at Data Theorem. At this point, I guess we'll hand it back over to the moderator.